Good day to all our great learners. Welcome to Bamboo Teleeskwela. This is your school on air in mathematics. Indeed, I am so glad to have you today for our discussion through our radio and telecasting mode of learning. I am John Paul P. Manabat from the Schools Division of Cauayan City. You can call me Teacher Paul, and I'll be your teacher for today. Before we continue our lesson, make sure that you are in a comfortable place and you can clearly hear me in the radio and or see me on your screen. Have you taken your snacks? It is very important that your tummy is full and your body is in good condition, so your mind is alert and ready to understand the lesson we are going to discuss today. Now, please get your module for the lesson Factoring Polynomials and your mathematics notebook. Again, I repeat, our lesson for today is Factoring Polynomials using Factoring Perfect Square Trinomial, Factoring General Trinomial, Factoring by grouping, and solving problems involving factoring. Are your module and math notebook with you now? This lesson is a continuation of your recent topics in factoring polynomials. But before we proceed, may I give you these important reminders. Please keep your module clean. Do not write anything on it. Instead, use scratch papers for your solutions and write your answers on your mathematics notebook. I hope it is clear. After listening to this broadcast or telecast, you are expected to factor polynomials and solve problems involving factoring polynomials. Are you ready? Let's begin with the first type of factoring. Factoring perfect square trinomials. This kind of product is the result of squaring a binomial. In symbols, we can have them in two forms. Quantity x plus y squared is equal to x squared plus 2xy plus y squared. Or quantity x minus y squared is equal to x squared minus 2xy plus y squared. But how do we know that a trinomial is a perfect square trinomial? For us to say that a trinomial is a perfect square, it must satisfy two simple conditions. Firstly, two of them must be positive perfect squares, x squared and y squared. And the middle term is twice the product of x and y. So the middle term must be a positive twice the product of x and y or negative twice the product of x and y. Now, let's have this example. Is 9x squared plus 30x plus 25 a perfect square trinomial? Let's have a closer look. In the first term, 9x squared is positive perfect square. The answer is yes. Congratulations! 9x squared is a square of 3x. Next, is the last term 25 a positive perfect square? You got it. Yes, 25 is the square of 5. Lastly, is the middle term 30x twice the product of 3x and 5? Your answer is yes? Then you are right. 9x squared plus 30x plus 25 is indeed a perfect square trinomial. Now let us try some more. Which of the following is a perfect square trinomial? Letter A, 4x squared plus 12x plus 9. Letter B, 9x squared minus 30xy plus 4y squared. Or C, x squared plus 7x plus 6. I will give you 20 seconds to decide on your answer. If you answered A, then you got the correct answer. The polynomials on B and C are not perfect square trinomials. Now, to factor a perfect square trinomial, you can use either of the following rules. X squared plus 2xy plus y squared is equal to quantity x plus y squared. Or x squared minus 2xy plus y squared is equal to quantity x minus y squared. These are the notable steps that can be used to find the factors of a perfect square trinomial. First, check if the trinomial is a perfect square trinomial. Second, find the square root of the first and the last term of the trinomial. Third, form a binomial using the square roots found in step 2, taking the sign of the middle term of the given trinomial. Lastly, square the binomial. Easy, right? Now let's put that to work. Let us factor a squared plus 6a plus 9. Does this fit the of our perfect square trinomial? The answer is yes. Now get the square root of the first and the last term, which are a and 3 respectively. Then form the binomial. Thus, a squared plus 6a plus 9 is equal to quantity a plus 3 squared. Now, it's getting clear, right? Now it's your turn. Factor m squared plus 12m plus 36. I will give you 30 seconds to do that. The answer is quantity m plus 6 squared. Keep it up. We are moving on with another type of factoring. Factoring general trinomials. Don't be confused. We are dealing not with just perfect square trinomials this time. Factoring quadratic trinomials consists of two forms. One is a quadratic trinomial where a is equal to 1. That is x squared plus bx plus c. And the other, quadratic trinomial where a is not equal to 1, that is ax squared plus bx plus c. For this to get clearer, let us find the product of the binomials quantity x plus 2 multiplied to quantity x plus 3 using the FOIL method. The resulting product for the first term is x squared, 5x for the sum of products of outer and inner terms, and 6 for the product of the last terms, giving us x squared plus 5x plus 6. The product x squared plus 5x plus 6 is of the form x squared plus bx plus c, where the coefficient of the squared variable is 1. Now, the constant c is a perfect square. Then proceed to factoring using factoring perfect square trinomial. If not, factor the product as two different binomials. The following steps would be beneficial in factoring quadratic trinomial of the form x squared plus bx plus c. First, find the two factors of c whose sum equals the coefficient of b. Then using the form quantity x plus multiplied to quantity x plus, fill this up with the two factors found in step 1. I hope you're still with me. Let us put that to work. Factor x squared minus 7x minus 18. Step 1. Find two factors of c whose sum equals the coefficient b. Since the coefficient b is negative 7, the factors to be used are 2 and negative 9. Step 2. Thus, x squared minus 7x minus 18 is equal to quantity x plus 2 multiplied to quantity x minus 9. Kind of easy, right? Now let's try this one. Multiply the binomials quantity 4x minus 3 and quantity 2x minus 1. The product is 8x squared minus 10x plus 3. This kind of form is ax squared plus bx plus c with a not equal to 1. This kind of form differs a little from the form x squared plus bx plus c. Now, there are steps that we can use in factoring quadratic trinomials of the form ax squared plus bx plus c with a not equal to 1. Firstly, factor out any common monomial factor. Next is to list all factors of a and c, then try and check the combinations of the factors of a and c until the correct middle term bx is obtained. Have a try on this one. Factor 3x squared plus 5x plus 2. What are the factors of a and c? Great! The factors are 1 and 3, and 1 and 2, respectively. Now, looking at our trial factors, quantity x plus 1 and quantity 3x plus 2 are the ones who can give us a middle term of 5x. Thus, 3x squared plus 5x plus 2 is equal to quantity x plus 1 multiplied to quantity 3x plus 2. Wait a minute. We must note that there are trial factors that have common factors, and these do not need to be tried because the correct factors have been found. Let's try and factor 3x squared plus 6x minus 9. Can you see a common monomial factor? Right. We can factor out 3 from the polynomial. Now, a is equal to 1. So we can simply get the factors of c, which is negative 3. Take a look at the factors of negative 3. Which pair will give us 2, or the coefficient b? Very good! Negative 1 and positive 3 is the answer. Thus, 3x squared plus 6x minus 9 is equal to 3 multiplied to quantity x minus 1 multiplied to quantity x plus 3. Let's try this next example. Factor 6y squared minus 11y plus 5. List the factors of a and c. The factors of 6 are 1 and 6, negative 1 and negative 6, 2 and 3, and negative 2 and negative 3. While the factors of 5 are 1 and 5, negative 1 and negative 5. Now, let us form some trial factors and observe which pair will give us the middle term negative 11y when multiplied using the FOIL method. Which pair are we looking for? Congratulations! You got the correct answer. Quantity y minus 1 multiplied to quantity 6y minus 5. Thus, 6y squared minus 11y plus 5 is equal to quantity y minus 1 multiplied to quantity 6y minus 5. Take note that if no factors of the Q number can be found, whose sum is the coefficient of the middle term, then the trinomial is prime and does not factor. Now is your turn. Factor the polynomial a squared plus 14a plus 13 using factoring quadratic trinomial of the form x squared plus bx plus c. I will give you 30 seconds to think of your answer. There you are. If your answer is quantity a plus 13 multiplied to quantity a plus 1, then you are correct. If you got a different answer, try looking back and keep trying. We shall move on with another type of factoring, factoring by grouping. This factoring is usually used when dealing with polynomials containing 4 or more terms. Let us try this one. Factor 3xy minus 21y plus 5x minus 35. First, let's try grouping the first and second terms, and third and fourth terms. Then factor out the common monomial factor for each group. Lastly, factor out remaining binomial factor, x minus 7. The answer is quantity x minus 7 multiplied to quantity 3y plus 5. Here is your turn. Factor the polynomial DWY minus 2WZ plus 4xy minus xz. I will give you 30 seconds for you to work on your answer. Here we go. The answer is 4y minus c multiplied to 2w plus x. Did you arrive with the same answer? If so, then you are ready with the next topic. But if not, don't give up. Look back and keep trying. Finally, we are ready with solving problems involving factoring polynomials. For us to be guided, we are going to consider some essential steps in solving word problems. First, we must understand the situation or the problem itself. Then try writing an equation. This will be our tool in getting the answer. Finally, proceed with carrying out the equation and of course, checking out the answer. Are you ready? Let's try this out in the first example. A square painting is surrounded by a 3 cm wide frame. If the total area of the painting plus frame is 961 square centimeters, what are the dimensions of the painting? Can you recall the steps earlier? First, we have to understand the problem. Let x centimeters be the side of the painting. X plus 6 centimeters be the side of the frame, and the given area of the frame and painting, that is 961 square centimeters. The problem tells us to find the dimensions of the painting. Since the area of a square is given by the formula A is equal to S squared, then the area of the painting and the frame is quantity x plus 6 squared, which is 961. Now, we are ready carrying out the equation. Begin with quantity x plus 6 squared is equal to 961. Then, expand square binomial so it will become x squared plus 12x plus 36. Using subtraction property of equality, subtract 961 on both sides of the equation. The right side of the equation becomes 0, and the left side will be x squared plus 12x minus 925, which can be factored to quantity x plus 37 multiplied to quantity x minus 25. Finally, we can solve for the values of x. The first value of x is negative 37, but there is no negative measurement. On the other hand, the second value of x is 25. Therefore, we shall consider 25 as our answer. Now, let us check our answer with 25 as the value of x. Since using 25 as the value of x satisfy the equation quantity x plus 6 squared is equal to 961, then our answer is correct. The dimensions of the painting are 25 centimeters. Are you ready? Now is your turn. The length of a rectangle is 2 more than twice its width. If the area of the rectangle is 24 square meters, What are the dimensions of the rectangle? I will give you 60 seconds to work on your answer. The answers are: width is equal to 3 meters and length is equal to 8 meters. Did you arrive with the same answer? If so, then you are ready with our next topic. But if not, don't give up. Look back and keep trying. Finally, we are done. I hope you learned a lot and don't forget the things we have covered with today's lesson. These are the factoring polynomials such as factoring perfect square trinomial, factoring general trinomial, factoring by grouping, and solving problems involving factoring. To deepen your understanding of the lesson, you may read or go over your module. Also, attach our additional activities for you to work on. If you have questions or clarifications, you can text or call your teacher, or you can message them through your group chat, messenger, or Facebook. If available, you can drop your output in the provided boxes in your respective school, or you can submit them to your teacher or facilitator on the scheduled day of meeting. You'll learn more on the next broadcast and our telecast. Be sure to tune in on our School and Air in Mathematics, same time every Tuesday. This has been John Paul P. Manabat, your mathematics teacher for today. Always remember that despite the pandemic, education is still possible. So never stop learning and soar high. Stay home, keep safe, and God bless everyone.